non-negative integer. So I'm given this n here. I'm given this n here. It's a non-negative integer. Non-negative integers are which number? It's a basically, it can be 1, it can be 2, it can be 3, it can be 4, and so on. My n can be anything, a non-negative integer. It cannot be negative numbers, can be any of these numbers, can be 0 also. Okay, it says n is a non-negative integer and let an minus 1, an minus 2 up to so on, a2, a1, a0 be any real numbers. These an minus 1, an minus 2, a2, a1, a0, they can be any numbers. They can be anything, but they cannot be complex numbers. They can be any real numbers, but they cannot be complex numbers. Okay. Also, with an not equal to 0. Only the condition is my first one. This an cannot be equal to 0. Other than that, it's okay. And it says the function is defined as fx is equal to an x to the power of n plus an minus 1 x to the power. Don't get confused. This is very easy. Don't get confused with this. I'm going to explain you all this. a2 x square plus a1 x1, or you just ax, you call it, plus a naught. So that's how you define a polynomial function. And it says is called a polynomial function with degree n. My degree in this case is n. The number an. So the coefficient of the highest degree, the number an, the coefficient of the variable to the highest power. Is called leading coefficient. Don't worry, don't get confused with what I'm writing here. I'm going to explain with examples. This will become out more clear. Okay, this big thing is confusing. But it's very easy when you understand. So let's take example. Let's take examples. I'm going to take various examples to figure out what are polynomials and what are not polynomials. So if you're given fx is equal to negative 3 x to the power of 5 plus square root of 2 x to the power of 2 plus 5. You are given this thing. They want you to check whether this is a polynomial or no. So the question says check if it's a polynomial. If it's a polynomial or no. How do you check is, first you're going to see all the powers, all the power of x. Here I have 5 and 2. They should be non-negative integers. Here I have 5 and 2. They are non-negative. That means one condition is good. Next thing I'm going to check is these constants here. I have next to my variables. -3, square root of 2 and 5. All these are real numbers. If all these are real numbers, then that means, and plus my this thing is non-negative integers, that means it is a polynomial. Since all the powers of the variable x are non-negative integers and all the coefficients mean the variables, all these numbers next to the variables, all the coefficients are all the coefficients are real numbers. Real numbers. That means it is a polynomial. Now next thing they ask you, if it's a polynomial, if they ask you what's the leading coefficient. So can I have Eduardo? Is Eduardo here? Yeah. So Eduardo, can you tell me what is the degree of this polynomial? Degree. I cannot hear you, Eduardo.
It's going to be something to do with between the 3 and the x, right? Or the main number.
The powers of x. Can you see the powers of x? Can you tell me what are the powers of x?
Yeah, it's x to the power of 5.
And yeah, x to the power of 5, and then you have x to the power of 2. The highest one is your degree. The highest one is your degree. So what will be the degree? So basically highest power. What is your highest power?
The x to the power of 5.
Just 5. Just 5. Just 5. So when they say degree, you look for just the highest power, and which is just 5. Not x to the power of 5, just 5. And if I say, what's the leading coefficient? So what's the leading coefficient, Eduardo? It says the coefficient next to the highest power. What's the coefficient next to the highest power?
That's the 2x squared, right?
No, negative 3. See, it's negative 3 times this thing, right? This is the highest power. So this is one term. And what's the constant in this term? Negative 3. Did you get it?
Yes, sort of.
So I again repeat. Degree is the highest power. So whatever is the highest power. So here I see power is 5, 2. And the highest one is 5. So my degree becomes 5. And for if they ask you to find the leading coefficient, how do you see the term with the highest degree. So I'm just going to look at this thing. Negative 3x to the power of 5. I'm just going to look at this thing and find the constant in that, which is negative 3. That will be my leading coefficient. Let's do more examples. You'll get with more examples here. If I say negative 3 square root of x plus square root of 2 x to the power of 2 plus 5. I take this example. Can I have Karen?
Yeah.
Yeah. So Karen, let's see the powers first. What are the different powers of x?
2.
Okay, this is 2. What about this one?
1.
What does square root mean?
1 over 2.
Yes, it means 1 over 2. So I can write it this way. Okay. I rewrite this in this form. So now what are the different powers? What are the different powers I have? 2 and 1 over 2, right? Can I have my power as 1 over 2?
1.
So note my powers can only be non-negative integers. In this, what are integers, Kevin? Non-negative integers? See the definition. It's written in the definition. I gave you the definition, right?
Yeah.
See, it says in the definition here, the n be a non-negative integer, 0, 1, 2, 3, 4. It could be 0, it can be 1, 2, 3, 4, 5, 6 and so on. But in this case, what's happening, Karen? What are my powers? It is 1/2 and 2, right? Is 2 my integer?
Yeah.
Is 1/2 my integer?
Yeah.
See, no, it is 0. It is not an integer.
Oh, okay.
Because 0, 1, 2, 3, 4, right?
Okay.
So that means 1/2 is not my integer. So that means this is not a polynomial. As soon as I
Okay,
found a
I got it.
power, yeah. As soon as I found a power which is not an integer, that means it is not a polynomial. If you did not get it, please raise your hand. You need to understand this, how to find the leading coefficient and the which are polynomials and which are not polynomials.
Okay, okay. So
Yeah.
the integers only is a
So integers,
complete number now, decimal or
yeah,
fraction.
fractions, yes,
Okay.
exactly,
Okay.
yes. Anyone else? Anyone who did not understand how to figure out these, which are polynomials and which are not polynomials? I'm going to do more problems on this. Let's see. Okay. Next example, if I take is gx is equal to, I take x minus plus 2 minus 3x to the power of 4. I take this. Was Shaira?
Yes.
Okay, Shaira, can you tell me whether this is a polynomial or not?
Yes.
Okay, first let's look at the powers. That means the variable x. What is x raised to power? What is x raised to power? What is the power of this x?
1,
And what about this x?
4.
Are those both non-negative integers?
Yes.
Perfect. So my n rule has passed. Okay, let's see the coefficients. What's the coefficient of x here?
1.
What here? It's just 2. What about here?
Sorry, it's lagging. -3.
Yeah, all of these are real numbers, right?
Yes.
That means it is my polynomial. It is a polynomial. First you check for the powers and then you check for the degrees, the coefficients, and then you can figure out. Okay. Next example, I'm going to take one more example is you are given, I say gx is equal to negative 3x to the power of 4, x minus 2, and then x plus 3. You have this thing. I say you have to figure out whether this thing is a polynomial or not. Note this is not in the standard form. This is not in the standard form. My standard form was something like this. My standard form was like this. Fx is equal to something plus something. So you had an x to the power of n plus some other term, so on up to a naught.
You can make it standard form, right?
Yeah, you're gonna make in standard form. Correct. You're gonna make it in standard form. How do you make it in standard form? Is open the bracket, start multiplying, open the bracket. First I'm gonna multiply these two brackets. What do you get? Negative 3x to the power of 4. If you multiply, you get first FOIL method. First terms, x times x, x square. O means outer ones, x and 3, 3x. I, inner ones, negative 2x. L, last ones, you get negative 6. Combine the like terms. You get this thing, you get x square plus x minus 6. Now you're gonna multiply this negative 3. It's like, so what does it become? It's negative 3, same base, different exponents, multiplying. You add the exponents, it becomes x to the power of 6. Then negative 3 times this. Again, negative 3 will remain as it is. What is x to the power of 4 times x? Same base, different exponents. Here it's 1. You add them. And then you get, multiply, you get 18x to the power of 4. Anyone who's not understanding this, please, let me know. I'll explain. This is just the beginning of polynomials. Polynomials are a little tricky, so make sure you understand what I'm explaining here. So in this case, we have to figure out whether this is a polynomial or not. Samantha?
Yes.
Yeah. Is this my polynomial or not?
Yes, it is.
What are the
Because,
different powers of x?
so the integers are non-negative numbers, so 6, 5, and 4.
Perfect.
Leading the coefficients, they are real numbers.
Yeah, and real numbers. What's my leading coefficient in this case?
It would be 18.
What's the highest degree? What's the highest degree?
Sorry, would be 6.
Okay. And what's the coefficient of the highest degree?
-3.
So the answer is negative 3. The coefficient of the highest degree.
Okay.
Yeah.
Thank you.
Perfect. Anyone who did not understand how to do this?
Yeah, I was a bit confused how you got negative 3x to the 5th power.
Okay.
Like,
So I multiply. Did you understand these two when I multiply negative 3x to the power of 4 times x square?
yeah,
Okay. Next thing, I had negative x to the power of 4 times x. I have to multiply these things. So first I get negative 3. Same base, different exponents. So what's the exponent here, Angel?
4? Oh, wait.
1. If it's not...
Okay, sorry, I didn't
and
see
then you
it.
add.
Oh, okay, so when we're multiplying exponents, we're just adding them?
Yes. When you have
Okay.
same bases, different exponents, you just add them.
Okay.
Yeah, perfect. Anyone else? Any doubt with this thing? Okay. One more example I'm gonna do is the last one, in which you have to tell whether this is a polynomial or not. Is you have gx is equal to, you have negative 3 over x square plus square root of 2 x square plus 5. You have to tell whether this thing is polynomial or not. Okay. So in this case, what we're gonna do is, first of all, this is not in standard form. My standard form is like this. I never had x in my denominator. I did not had my variables in the denominator. So I take this in the numerator. How do I take it? I told you we can do that by changing the positions. I take it in the numerator, but my exponent will become opposite sign. If it's positive at the bottom, it will become negative in the numerator. You just change the sign. When you change the position of the variables, you change the sign of the exponents, and everything else remains the same. Okay. Hugo?
Yes,
Okay. Can you tell me whether this thing is polynomial or not?
it's not a polynomial
Why?
because you have a non-negative integer for your degree.
Yes, perfect. It's not a polynomial. It is not a polynomial, as one of the powers of x is a negative integer.
Can you show how you got that negative 3 over 2x, how you did that negative 3x with the power negative 2?
Yes. So when you have negative 3 over x square, whenever you have something at the bottom here and you have to change, you have to make it positive, you have to take in the top. So negative 3 is already in my numerator. I'll keep it. But I need to take this on the top here. What you're going to do is, I'll take it on the top. My x will remain x only, but my exponent changes its sign. My exponent will change its sign. If it's positive, it will become negative. Another example, if I say 1 over x to the power of negative 2. I have this thing. You take in the numerator. I want you to take this in the numerator. What you're going to do is, you're going to keep x as it is. My base here will remain as it is, whatever it is. Only the sign of the exponent will change. Since here it's negative 2, it will become positive 2. That's how you do it with the exponents. Did you get it, N1? That's a rule. With you guys, did I do exponent functions or not? I've been missing so many classes. No, we did not do. We just did functions with you. So maybe in your further syllabus, we'll do exponents functions where you will see this. Just remember like this. So if you have in your base, you can take in the numerator by changing the sign. And Wanda, are you getting it?
Not really, but
the thing is, the rule says if you have a to the power of n, 1 over a to the power of n, that's the rule of exponent functions. If you have something like this, you can keep a as it is, and you can take in the, these are equal. That's a rule of exponent functions. Maybe we'll be doing exponents in your syllabus also. I don't remember in pre-calc. And there you will learn this
okay.
property.
I remember that. I remember learning that. Okay, I remember.
Yeah. Anyone else? Any doubt so far? Okay. So next thing what we're gonna do is, let's see. So first of all, for graphing for polynomial functions, so we are gonna talk about graph of polynomial functions. Graph of polynomial functions. One thing you should know about graph of polynomial function is that it is continuous and smooth. What does that mean? It's continuous and smooth. So basically, you can graph the polynomial in like one go, like without lifting your pen. That's continuous. You don't lift your pen when you are graphing your polynomial function. Okay, smooth means it doesn't have like sharp turns. It doesn't have sharp turns. That's what it means by smooth. Continuous, I again repeat, continuous, it will go like without lifting your pen. You can draw in one go that graph. That means it's continuous. Smooth means it doesn't have any sharp turns. So let's take an example. If I say, let's see, I'll show you here. If you see here in this examples here, we are doing here. If you see the first example here, see it is, you can draw this in one go continuously without lifting your pen. So this is a polynomial function. It's smooth and continuous. But what about this one? If this one, I see this one here, I start drawing here. First of all, there's sharp turns, there's sharp corners here. It's not smooth, so it's not polynomial. But if you see here also, it's not continuous. There is a gap. I have to stop here and then I have to start again. So it's not even continuous, so it is not a polynomial function. So by looking, you can tell whether it's a graph of a polynomial function or no. How do you see is, you start drawing. See if there is no sharp turns. Okay, if there is sharp turns, it's not a polynomial. Also, you can draw it in one go or not. Since I can draw this graph in one go without lifting my pen, and also it does not have any sharp turns, it is a polynomial function. Let's see if they have more examples on this. No, they don't have more examples on this. Any doubt? Okay. Next thing what we're gonna go to is something known as end behavior of polynomial function. End behavior of, so now it's important. So polynomial function. End behavior of polynomial function. So first of all, this is a step 1. So this is the step 1 for graphing. You have to figure out the end behavior of polynomial functions. What does end behavior mean? How will be my graph at the end? How will my graph look at the ends? How will it behave? How do you check is, there is something known as leading coefficient test. There is something known as leading coefficient test. For this step 1, you're gonna do leading coefficient test. What is leading coefficient test is, first you're gonna look at your degrees. So degree means the highest degree. So if your n is odd, you're gonna check whether n is odd or n is even. Even basically means n is 2, 4, 6, 8, any number which is divisible by 2. Or is it an odd number which is not divisible by 2? 7, 9, and so on. You have to check whether your n is odd or n is even. Once you check your n, you have to check the an, which is your leading coefficient. You have to check your an. If your an is greater than 0 or an is less than 0. Here also you have to check whether an is positive number or an is negative number. If your n is odd and your an is greater than 0, your graph n behavior will be like this. And if it's less than 0, it's going to be like this. If it's even and it's greater than 0, make sure you make these notes. About this leading coefficient test, your book does not have these notes. I'm explaining you in an easier way. Your book explains in a more complicated way. This is easier way to figure it out, your n behavior. And if it's even and greater than 0, both sides will be facing upward. And if it's negative, both sides will be facing downward. Let's take an example. I'm going to take example here. Let's take example. You have to use, it says, use the leading coefficient test to determine the end behavior of the graph of fx is equal to x cube plus 3x square minus x minus 3. So this is a polynomial which is given to you. They wanted to use a leading coefficient test to determine the end behavior of this thing. And I have Angel. I need to figure out my an and an. Angel. Okay, he's not here. Miguel. Miguel.
Yes.
Okay. In this case, can you tell me what's my n?
3.
Yes, n is 3. The highest power. The highest power. Perfect. What's my an?
1.
1. Perfect. Is my, first let's check n. First I have to always check n. Is n my odd or even here?
It's odd.
Odd. Since it's odd, I'm just going to look at this side. I'm just going to look at this side. Okay, an is 1, which is positive number or negative number?
Positive.
Positive number. How will my graph look like?
Up and down.
Yes, first will be down. Note, first will be down. So this
Or
side,
down
my graph will be down, and this side, my graph will be up. So I know that's how my end of my graphs will look like. Perfect. Okay. So this is the end of my graphs. That's how my graph is going to look like. So you should know how to figure this out. That's the first step of graphing. You should know the end behavior. And you should know how my ends of my graphs will look like. Let's do one more example. So you have, let's see. Okay. I want everyone to try this themselves. So you have x to the power of 4 minus 4x to the power of 2. I want you to check how does a graph behave. I want everyone to try this. Christopher?
Yes.
Okay, what's my n in this case?
Your n in this case is 4.
And an is?
An
An is?
greater than 0.
An is, well, an is the coefficient of highest power. What's the coefficient of this
Oh,
thing?
it's 1. Sorry.
It's 1. Perfect, perfect. Okay, n is even or odd?
An is even. Or n is even.
N is even. You always look n for even. When it's even, that means I'm going to look for this side here. I'm just talking about this side here. Let's look at my an. My an is positive or negative?
Positive.
It's greater than 0. It's positive. What happens when my n is even and an is positive?
Both ends are up.
Both ends are up. So my both sides of my ends of my graph will be upward. That's how my graph is going to look like. Perfect. Anyone has any doubt with this step here? This is your first step, how to figure out the end behavior. I'm going to take one more example. So you have fx is equal to negative 4 x to the power of 3 x minus 1 x to the power of 2 x plus 5. You have this thing. You have to figure it out whether this, you have to figure out the end behavior of this polynomial. How are you going to do it? You open it, you multiply, you open it. That's one way of doing it. But it's too complicated. There is an easier way of doing it. There is an easier way of doing it. How can you do it is, okay, from this term, how many, what's the degree of here x? 3. So in this case, its degree is 3. From this term here, if this is confusing you, I'm telling you an easier way of doing it. If this thing is confusing you, just open it and see what's your n and what's your an. In this case, what you can do is, see here, x minus 1 whole square. So if you open it, if you try to see in your mind x minus 1 whole square, that means you're multiplying x minus 1 twice. Square means you're multiplying that thing twice. So you're basically multiplying x minus 1 times x minus 1. Since degree here of x is 1 and degree here is 1 and degree here is 5, what you're going to see at the end, you know what will be your degree, the final degree? The final degree will be basically you add all of these. So if you get something like this, which is not in standard form, this is an easier way to find the degree. This is the easier way to find the degree. Since here it was 3, so here it will, final degree will be 3 plus 1 plus 1 plus 5. Sorry, not, it's 1 here, plus 1. You get 6. If you have it this form. If you don't understand this way, try to open it and then see what's your degree. You will still get your answer as 6. Let's open it. I want to see if it's open it. Let's open it. Minus 4 x to the power of 3. X minus 1 times x minus 1. Foil. Use foil. First, outer, inner, this. You will get x squared minus x plus 1. And then you have x plus 5. Do it this way, it's confusing you. This is also the same thing. Minus 2x plus 1 and then you get x plus 5. Again use a FOIL method here. So first, once you get x cubed, then you get 5x squared, negative 2, then I'm multiplying negative 2 here, you get negative 2x squared, negative 10x, and then 1, you multiply, you get x plus 5. I'm distributing it. First I took x squared, I multiplied with x plus 5. Then I took negative 2, I multiplied with x plus 5. Then I took plus 1, I multiplied with x plus 5. This is what I got. Then you simplify it. Combine the like terms. X cubed, there is no other term. X squared, it's these two, so you get 3x squared. X, you combine these two, you get negative 9x plus 5. Try to combine again. Open the bracket, multiply. Open the bracket. You get negative 4x to the power of 6. Negative 12x to the power of 5 plus 36x to the power of 4 minus 20x to the power of 3. That's what you get. Note, I directly told you my degree. Before I directly told you my degree. You can do it that way too or this way. If that thing is confusing you, just open it and figure out what's your degree and your AN. Otherwise, you can figure out directly. So in this case, your degree comes out, your N comes out to be 6 and your AN comes out to be negative 4. It means it is even. When it's even and a negative number, how does it look like? Both will be downward. Both will be downward. Anyone has any doubt with this problem? Anyone needs any help with this problem here? Okay, so this was your first step. So first step we did with graphing is you will always figure out your n behavior. For n behavior, you're gonna do the leading coefficient test. You're gonna see your n is even or odd, and then you're gonna look at your an, if it's positive or a negative number, and then you're gonna solve accordingly. Next thing what we're gonna move is finding the zeros. Next thing is step 2. Step 2, zeros, or you can say x-intercept of, it means the same thing. Zeros or x-intercept, it means the same thing, of polynomial function. Zeros and this thing of a polynomial function. Note, in this case you will get 3 kind of problems. In this case you will get 3 to 4 kind of problems here, how to find zeros and x-intercept of a polynomial function. How you're gonna do it is, so if you get something like this, if your equation looks like this, so if your equation looks like ax square plus bx plus c is equal to 0. If you have a polynomial like this, or is equal to fx, they say fx is equal to this thing. How do you find zeros of this thing is, use quadratic formula and find the zeros. You know what's the quadratic formula? It's x is equal to negative b plus minus square root of b square minus 4ac over 2a. If I say find the x-intercept of this kind of equation, the highest degree is 2. The highest degree is 2, so highest power is 2. In this case, figure out what's your a, b and c and plug in this formula and find the value of x. This is the easiest way of doing it. Okay, there is another form of equation. Suppose you get equation like this. You get fx is equal to x cube plus 3x square minus x minus 3 is equal to 0. Also, is equal to this. Okay, you get this thing. I say you figure out what are the x-intercepts. For x-intercepts, what do? You put y is equal to 0. I put this y is equal to 0. Fx is basically your y. I put y is equal to 0. Then I say find the values of x. In this case, when you have a cube here, cube means 3. Note, in quadratic, you're gonna, when it's a square, highest power is square, you're gonna use this formula. But when it's a 3 here, what you're gonna do is try to combine. First you write in the standard form. First the 3 term, then the 2 term, then the 1 term, and then the constant. Write in the standard form, then combine two terms. I combine the first 2 terms and the last 2 terms. Combine them and see what's common between them. What's common between them? Can I have Joshua?
Yep.
Yeah. Okay, Joshua. What's common between x cube and 3x square?
They're both raised to a certain power.
Yeah. So what's common? Like this one has 3x, right? X cube means x times x times x. This has 3 and x square. What's common between them?
They both have x's.
How many?
The first one has 3 and the second one has 2.
So what's common between them?
They have more than 2.
See, let's see. You have here, you're saying you have 3x, here you have 2x, right? What can I take out? I need something which both of them have.
They both have 2 x's.
So I take out 2 x's. I took out 2 x's. Okay. What am I left inside? From this term I took out 2 x's. What am left inside?
X plus 3x.
3x?
Or plus 3.
Just 3 because you took out 2x already. You took out these 2x, you took out these 2x. You're left with just x plus 3. Okay. From this, Joshua, can you tell me from this thing? Negative x and negative 3. What's common?
There's nothing common from that.
But try to make this thing. I want to make the same thing. X plus 3. I want to make this as x plus 3. So what's common between them?
Oh, the negative symbol.
Yes, the negative symbol. If I take it out negative 1, how do I take it negative symbol is I take out negative 1. What I'm left with inside?
X plus 3.
Perfect, perfect. Any doubt till this step, anyone?
How'd you get the x to the power 2?
Okay, so see, the first term here, Samantha, x cube, right? Cube means there are 3 x's, x, x, x. X square means there are 2x. What's common between them? This has 3x, this has 3 and 2 x's. So the common between them was 2x, right? I took out 2x outside.
Oh, okay.
And what I'm left with inside is 1x and positive 3. Got it?
Nice. Okay, yeah.
Next thing after this thing, next step is what you're going to do is, now you're going to look at this. You have this time this minus this time this. Now you have two terms. Two terms are separated by addition or subtraction sign. Terms are separated by addition or subtraction sign. So you have this times this whole thing minus this one times this whole thing. See what's common between them. Erica. She's not here. Daniel. Is Daniel here? No. N1
Hello.
Yeah. Hello. So in this case you can, so we have these two terms. Now this is my one term and this is my one term. What's common between them?
They both have x plus 3.
So I took out x plus 3 now outside. What am I left with?
X squared minus 1.
X squared minus 1. Once you got this thing, what you have to do is, you got something multiplied by some other term. You have some term multiplied by some other term. What you're going to do is, to find your x-intercepts, what you're going to do is put each and every term equal to 0. Put each and, so I'll put x plus 3 also equal to 0 and x squared minus 1 also equal to 0. And then solve for x. When I solve this for x, I subtract both 3, I get x is equal to negative 3. That's one of my answers. Let's solve this thing here. So you add 1 both sides. I get x square is equal to 1. Note, opposite of square is square root. Note, I am taking square root myself. Square root was not there. So you are going to put a plus minus sign. Don't forget to put a plus minus sign. You get x is equal to plus minus 1. So these are the three x-intercepts you got. Negative 3, positive 1, negative 1. So this is a special kind of problem you'll get. So if it's, you get a quadratic, just use quadratic formula directly. But if you get something like this x cube, combine the terms and try to solve it. Any doubt? I want everyone to try this problem. So you are given, you have to find all the zeros. You're given fx is equal to x cube plus 2x square minus 4x minus 8. Try this problem right now.
For this one, we're just finding the x-intercepts.
Yes, just the x-intercepts. Jesse? Is Jesse here? Jose?
Yeah.
So Jose, you'll be giving me answer to this one.
All right. Your zeros are -2 and 2.
Perfect.
But
Negative.
it's a degree 3.
Yeah, so which one you got twice? You might have got something as twice.
It's because the square root of so for the second one, when you have x squared minus 4,
Yeah.
and I set it equal to 0, you would subtract or add 4 and then get the square root of that. So we get the plus or minus 2.
So you're getting this thing, right?
What was that?
You're getting x is equal to 2 twice, right?
Yeah.
So you have to write it twice. You don't have to write it once, you have to write it twice.
Then that would be -2.
Negative 2 is coming twice?
Let's
see.
Yeah, because one of them should be x plus 2 and the other one is x squared minus 4, right?
Yes, perfect, yes. So you get -4, you get x plus 2, so you get x square minus 4 and then you get x plus 2. Perfect. And then you subtract equal to 0 both of them. From here you get x is equal to -2. From here you get x square is equal to 4. Take square root on both sides, put a plus minus sign, you get x is equal to plus minus 2. So you get -2, -2 and 2. Perfect.
So isn't that a whole?
Whole mean?
A whole? Or is that for just like
No, there is
the
no hole.
rationals?
There is no hole. It's just
Oh,
touching the x-axis at that point. We're going to learn
Okay.
about this. I'm going to explain this point. What happens when you have like this 2 times it's coming. Yeah. Any doubt how to do this problem here? When you have a third power here. When it's a third power and you have 4 terms, that's what you do. You combine two terms and try to find your zeros. Okay. Next thing we're going to do is 6th. So other thing, okay, is if you get problems more than 3, you know, when you have something like more than degree 3. So what we did so far is degree 2, use quadratic formula. Degree 3, I told you that degree 3 and 4 terms, combine the two terms and try to find your zeros. But what happens if you have more than that degree? So example, if I say find the zeros for fx is equal to negative x to the power of 4 plus 4x cube minus 4x square. I say, in fact, for any problem, whether it's degree 2, whether it's degree 3, whether it's degree 4 or degree 5 or any degree, first thing what I will try to do it is try to take out common. Is there anything common between all the terms? Is there anything common between all the terms? So here you have minus x to the power of 4. So this is one term, then this term, then this term. You have 3 terms here. Now we need to figure out what's the common between all of these terms. Alejandro? Axel?
Yes, ma'am.
Oh, Alejandro is here. Okay. Alejandro here. Can you tell me, so I have this term, I have this term, and I have this term. What's common between them?
X. Very well.
I cannot hear you properly. What is it? Okay, Alejandro, I cannot hear you. It's okay. Can I have Axel? Axel is not here. Jelena? Carly?
Yes.
Okay. Can you tell me what's common between this, and this?
X squared.
We're saying it's common is x squared. Okay, I took out x squared because this has 4x. See, x to the power of 4 means this term has 4x, this has 3x's, this has 2x's. So all of them have 2x's, so I took out 2x common. Okay, what I'm left with?
X squared, and then it would be negative x squared.
Yeah.
Plus 4x. And then minus 4.
Minus 4 equal to, since it's y-intercept, we have to find the x-intercept, we put fx as 0. Perfect. Once you got this, what you're going to do is, you're going to put each of them equal to 0. X square is equal to 0. And then you're going to put whatever you have inside that also equal to 0. So you can do this way also. So whenever you have a problem, they ask you to find the zeros. First thing you will do is always, no matter what problem it is, try to take out common. Once you took out common, you're gonna put each and everything equal to 0. Now let's solve. X square is equal to 0. Again, opposite of square is square root. Whenever you put a square root yourself, you have to put a plus minus sign. You get x is equal to plus minus 0. But there is nothing known as plus minus 0. So basically you have x is equal to 0, x is equal to 0. From here, I told you when you have a square, what you're going to do is directly use the quadratic formula. Directly use, what's your a? A is the coefficient of x square, which is -1. B is the coefficient of x, which is 4. C is the constant. Put in the formula. Minus b plus minus square root of b square minus 4ac over 2a. Let's see, you get -4 plus minus 4 square minus 4ac over 2a. You get -4 plus minus 16 minus 16 over -2. When you solve, you're gonna get -4 plus minus square root of 0 over -2. So you're gonna get -4 over -2, which is 2. You got x as 2.
Wait, wouldn't it be 16 plus 16 because it's
Oh,
b squared minus 4ac?
yeah.
Be
So,
negative
but
4 times negative 4.
a was -1, right? Negative makes it positive, and then positive times negative makes it negative.
Oh, I didn't see that one. Okay.
Yeah, perfect. Yeah. You know one thing, if you have noted, see here you had x square, right? You had x square, you got 2 zeros. So whatever is the degree, that many zeros you're gonna get. Note my highest degree was what in this question? 4. It was 4. You're supposed to get 4 zeros. You're supposed to get 4 zeros. The number of degree, the number of the part, that many zeros you're gonna get. Here it's 4, so you're gonna get 4 answers. 1, 2, 3. What's the fourth one in this case? Note it was x square. When in this term, from this thing you got 2. From x square, when this side, you got only one answer. That means actually this thing is coming up twice. So x is equal to 2 is coming up twice. You will see why we need this, why we are writing it twice. You will see next step is this thing, why we are writing it twice. Once you're done, I want everyone to do this problem. Fx is equal to a given fx is equal to x to power 4 minus 4x square. I want everyone to do this and find the zeros. I want you to find the zeros. Jelena? Hawking? Hawking is not here. Nicholas? Nicholas? It's not here. Was? Erica?
Yes.
Was is it? Okay. So was my first step.
You sub the common.
What's common between them?
X squared.
Okay, I took out x squared. What I'm left with?
X squared times x squared minus 4.
X squared minus 4. Perfect. What's my next step?
Then you equal them both by 0.
Yeah, I put x squared is equal to 0, then x squared minus 4 is equal to 0. Perfect. From this, so since it's x squared, from here I'm supposed to get 2 zeros, from here I'm supposed to get 2 zeros. Okay. What do I get from here?
From x squared, x is equal to 0, then x is equal to 0.
Perfect. From here, what do I get?
X is equal to -2, x is equal to 2.
Perfect. Anyone has any doubt how to do this problem? So always try to take out common. In any problem, always try to take out common. So right now what we are talking about is x-intercepts. End behavior, you know, the first step. Next step was to find the x-intercept, and right now we are talking about x-intercept only. With x-intercept, there is something known as multiplicity. Next thing, within this step only, there is something known as multiplicity. Multiplicity of zeros. And we call it by k. We call it by k. What you're gonna do is, you find your zeros, you find your x-intercepts. K tells me how many times is it coming. How many times is that zero coming? Once, twice, thrice. That's what it's telling you. So let's see. You're gonna write here, if it says, I want to write the definition. It says if R, this is R, okay, R is a zero of even multiplicity, then the graph touches the x-axis and turns around at R. This is R, okay. If R is a zero of, or zero x-intercepts, they mean the same thing. Zero multiplicity, then the graph crosses the x-axis at R. That's what it says. So what does the definition means is, what do you mean by definition is, so let's take an example. I'll explain you with an example. Okay. They say if you're given, suppose you were, okay, let's take a previous example we did fx is equal to x to the power of 4 minus 4x squared. When you solve this in the previous example, what did we get? We get x is equal to as 0, we got x is equal to as 0, we got x is equal to as 2, and we got x is equal to as negative 2 as our answer. These are the 4 answers we got. You know how do we write multiplicity is? So now we're going to find the k. We are going to find k for each 0. So you got x is equal to 0, you got x is equal to 2. These are the separate, different kind of zeros you got. These are the different kinds of x-intercept you got. How many times was 0 coming here? Twice. So my k for x is equal to 0, my k will become 2. Now x is equal to 2. How many times was it coming here? Only once. So in this case my k is 1. What about negative 2? How many times was negative 2 coming? Once. So in this case my k is 1 again. So that's why we were writing it twice. Because you need to find the multiplicity. So now what we did is, we figure out the end behavior. So we are done with graphing 2 steps now. For graphing we are done with 2 steps. First we figure out the end behavior. Can I have Carly? Okay.
Yes.
Okay. What's my n in this case, in this example?
4.
Okay. And what's my an?
1.
N is even or odd?
Even.
An is positive or negative?
Positive.
What happens with even positive?
It goes up.
Both of them goes up. So I know my end will look like this. Both of them will look like up. Now I found my x-intercepts as 0, 2 and negative 2. I know my graph is gonna touch at this point, 0, 0. 0, 2, 1, 2. It's gonna touch at this point and this point. These are my x-intercept. That's what it means. These are the 3 points my graph is gonna touch. This is my second step. You know what does multiplicity tell you? Now multiplicity, if it's a even multiplicity, if it's a even, see here k is 2, which is even. Even means numbers divisible by 2. 1 is not even, odd. 1 is not even, odd. When it's even, you know what will happen? My graph will go, touch that point and turn around. It will not cross the axis. If it's an even multiplicity at that point, since 0 had even multiplicity, my graph will go there near that point, but it's going to touch and turn around. If it's an odd multiplicity, my graph will go there, touch that point and will cross. So at these 2 points my graph is gonna cross because they have odd multiplicity. So this is my second step. I'm not joining right now, I'm just trying to figure out what my graph is. So second step was to find your x-intercepts and find their multiplicity. How many times are they coming? If they're coming even number of times, they're going to touch the graph and turn around. They will not cross at that point. But if it's odd, they're going to cross at that point. Any doubt? That's the next step, step 3. So step 3, find y-intercept, which is easiest to do. How do you find y-intercept? You put x is equal to 0. Just put x is equal to 0, you will find your y-intercept directly. That's what we do in all the problems. You put for y-intercept, put x is equal to 0. That's it. Next thing it says is step 4. Step 4 it says is find additional points if necessary. Find additional points if necessary. That's it. Let's graph it now. Let's do the problem. Let's do a problem. Let's do a problem. So you are given, I'm going to do one example for graphing is, you're given fx is equal to x to the power of 4 minus 2x squared plus 1. You're given this thing. We have to graph this. They are saying we have to graph this. Let's see step 1. End behavior. End behavior. We're going to talk about end behavior. Jelena, Axel, Alejandro. Yeah, Alejandro. What's my n in this case?
Pardon?
What's my n?
Stand again.
Okay, I need to find the n behavior. What's my n in this case? What's the degree in this case?
I'm sorry, I'm not attending.
You need to find the degree. What's the degree of this polynomial?
Oh, like the slope?
The highest power. What's the highest power of this polynomial?
Oh, infinite?
Hmm?
Yeah, infinite?
What's the power of x here?
It's power 4.
What about this one?
2 power 2.
Okay, what's the highest number out of those?
Oh, 4.
Okay, that's a 4. An means the coefficient. An means the coefficient of the highest degree. What's the coefficient of this term? What's the number with this term? Alejandro? You don't know? If there is no number, there is 1. If there is nothing, there is 1. Jose?
Yeah.
When you have n as 4, it's even or odd?
That's an even degree, and your leading coefficient is greater than 0, so your end behavior is going to be both facing up.
Both raising up. So let's start graphing on the side. Let's start graphing on the side here. So you're saying my something both is facing upward. Perfect. Step 2. I need to find my x-intercepts. So x-intercept, what do? You put y is equal to 0. You get 0 is equal to y, fx is the same thing. I put equal to 0. How do you solve this thing? I told you first you will always try, no matter what problem you have, you will always try to take out common. Here I have x to the power of 4. I have here negative 2x to the power of 2. Here I have 1. I have these three things. What's common between all of these three? Nothing. There is nothing common. This has 4 x's. This has 2x and negative 2. This has just 1. This does not have any x. So I cannot take out anything. When you cannot take out, you are like, oh, I cannot even use quadratic. Because here it's x to the power of 4. I can use a quadratic only if it's x to the power of 2. I cannot use a cube thing because there are not 4 terms. Otherwise, I would have made pair of 2's. So what's the next thing? This is a special kind of problem. This is a special kind of problem too. In this case, what you're going to assume is, you'll assume x square is equal to as u. Suppose x square is your u. So in this case 0 is equal to, if x square as u, what does x to the power of 4 becomes? 2 x's make it u. 4x will make it what? Jesse?
X squared.
Yes, you're correct.
U squared.
Yeah, u squared. So it will become u squared. Anyone who did not understand why I'm writing x to the power of 4 as u square? Anyone wants me to explain this part?
Could you explain it?
Okay. So I'm assuming x square. Whenever you get something like this, something like this, I will ask you should assume x square as u. Why? So you have x4, right? x4 means you're multiplying x 4 times here. So you have x times x times x times x, right? I'm calling these two as u, right? That's what I did. I assumed x square as u. So this is also u because I'm taking this also as u. What does this become? U times u to the power of 2.
U squared.
Yeah. Did you get it?
Yeah.
Yeah.
Thank you.
Minus 2. Now what is x squared? We directly know, we just assume that as u and then plus 1. Note this becomes a quadratic function. This becomes a quadratic function. I know how to solve this. Find your a, find your b and find your c. Okay. When you find your a is the coefficient of the u square, which is 1. The coefficient of u is negative 2 and constant is 1. Negative 2. 1. Put in the formula. Note it's u is equal to, not x is equal to, because now you're solving, this is your formula, you're using this thing. So it becomes u is equal to negative b plus minus square root of b square minus 4ac over 2a. When you solve, you get 2 plus minus 4 minus 4 over 2. You get 2 plus minus square root of 0 over 2, which is 2 over 2. You get 1. You get u as 1. Note you started with u square and you're getting only one answer. That means it's coming out twice. I don't want my answer in u. I want my answer in x. I wanted the answer in x. I'm getting the answer in u. So I'm going to substitute back. What I've assumed, u as x square. So I basically get x square as 1 and x square as 1. Try to solve. Take square root on both sides. Whenever you're taking square root, you're going to put a plus minus sign yourself. You get x is equal to plus minus 1 and x is equal to plus minus 1. So basically your answer is x is equal to 1, x is equal to negative 1, x is equal to 1 and x is equal to negative 1. So basically you have x is equal to 1 and these are the two things. What's the multiplicity of x is equal to 1? Can I have N1 die?
Hello?
Hello. So x is equal to 1, right?
Yes.
So what's the k? What's the multiplicity of x is equal to 1?
1.
Why 1? How many times is 1 coming here? These are the zeros I got.
Looks like 4 times.
1, just 1.
Oh, 2. Wait, what? Ooh, 2.
2. So k becomes 2 for k, x is equal to 1. What about negative 1? How many times is negative 1 coming?
2.
So in this case, the multiplicity of negative 1 is 2 also. What happens when it's an even multiplicity?
You add them together?
No. Even multiplicity, what happens? So I know my graph is, this is my x-intercepts, right? I know my graph is touching at this point and this point. My graph will cross at this point, will touch this point. What happens when it's even multiplicity?
It touches the x-axis.
Yeah, it will touch and turn around. It will touch and turn around. It will not cross. It will touch at that point and turn around. So at this point also it will touch and turn around. Are you getting my point? Any doubt with step 2?
Yeah.
Step 2, x-intercepts, anyone who did not get it. First you try to find your x-intercepts, all whatever you got. Then you write the unique ones, which one you got, x and -1. And then try to find multiplicity. How many times are they coming? That's known as multiplicity. If it's even, it's going to touch and turn around. If it's odd, it will cross at that point. So this is my graph so far. Let's go on further steps. Step 3, y-intercept. Y-intercept, which is easy. For y-intercept, what do? Put x is equal to 0. So you had f of x, this was your question, x to the power 4 minus 2x squared plus 1. Put x as 0. You get 0 to the power of 4 minus 2 to the power of square plus 1. You get basically y is equal to 1. So y-intercept is basically 0, 1. So if this is 1, this is, suppose this is 1. This is the point my graph is gonna cross. This is the point my graph is gonna cross. Any doubt? If you want to find additional points, I mean, at least find 1 or 2 additional points. Let's find 1 or 2 additional points here. Step 4. Let's find few additional points.
I think it's funny that you like put 1 on the left side and -1 on the right side.
Oh, sorry, yeah. Sorry. Yeah, you're correct. I'm sorry. It's supposed to be like this, yes. Take additional points. I take x as, so I already found as 1, 0, -1, 0, 0, 1. These are all the points I already found. Let's take 1 or 2 more. I found 3, let's take 1 or 2 more. I take x as 2. X as 2. What happens when you put here 2? What do you get here? You get f of 2 as 2 to the power of 4, -2, 2 to the power of 2 plus 1. You get 16 minus 8 plus 1, which is 8 plus 1, which is 9. For 2, you're getting something as 9. So this is your 2 here, so you'll get something as 9 here. So you're getting somewhere here. No. Now you can start graphing. Join them. So here it goes here, see. At this, it's gonna go cross, touch, join them, and here it's gonna go up and something like this. That's how your graph looks like. I mean, I haven't drawn accurate, so it looks weird, but that's how you do it. In random, like, these are the points. These are the main things they're going to look for. Your x-intercepts, how you're drawing, and your y-intercept, and your end behavior. These are the main points that they're looking for. Let's do one more. Yeah, okay. First, before doing this, I want everyone to try this problem. Fx is equal to, so you're going to try this. Fx is equal to x cube minus 3x squared. Start graphing this. X cube is equal to, Fx is equal to x cube minus 3x squared. Hawking. Karen? Karen? Shaira?
It's me or no?
Karen? Yes. So let's do step 1. Step 1 is what?
I'm sorry, I can't hear.
Step 1 is end behavior. How do we figure out the end behavior, Karen?
Is n is equal 3
Yes. En is?
and 1.
Okay. N is even or odd?
It's
It's odd. En is positive or negative?
positive.
Positive. What happens when odd and positive?
Is up and down.
It's up and down or down or up?
Oh, okay. Down and up.
Yeah, it's down and up. Make sure you remember that. It's not up and down, it's down and up when it's positive. When it's negative, it's the opposite. So if I graph here. So I know it's gonna look like this now. It's gonna look like this. Was
Yes.
okay. What did you find the x-intercepts as?
The x-intercepts are x is equal to 0, 2 zeros, then x is equal to 3.
X equal to 3. Perfect. Anyone who did not get these x-intercepts? Okay, can you tell me, so basically you got x is equal to 0 and x is equal to 3. What's the multiplicity of 0?
0.
Yes. And what's multiplicity of 3?
1.
So what happens at 0 was?
It bounces up.
Yeah, it bounces. Yes, it's gonna touch and bounce up. What happens at 3?
It crosses.
It crosses. Okay, it's gonna cross here. Perfect. I know my graph's gonna look something like this. Perfect. Because it's odd, it's crosses, even it's gonna bounce up. Okay. Shaira?
Yes.
What's my next step?
Finding the y-intercept.
Okay, finding a y-intercept, and how do you do it?
Substitute all the x's with 0.
What did you get your answer as? Y is equal to?
Zero.
Got y is equal to what? When you put x is equal to 0, what did you get y as?
Y equals 0.
Yes, perfect. So 0, 0. Again, this point is this thing. Step 4, find additional points. Just in case you want to find additional points. I don't have any sign here, so I'll take -1. Let's put -1. What do you get? You get fx as f of -1 as -1 cube minus 3 -1 squared. So you get -1 minus 3, which is -4. -1, -4. So basically -1, 1, 2, 3, 4. So you'll get something here. This is my point. Let's join this together now. So this is one point I found. So definitely I put this thing there, starting with there. Oh, you are like, I'm supposed to, after this, I'm supposed to connect this thing. But you're like, oh, it's going upward. I'm supposed to connect it. Okay, this side is going to be up here. It's down here. I cannot connect these. Because if I try to connect it, it's going to cross. the x-axis. It's not supposed to cross the x-axis. So note everyone in this case, very important thing. I said it touches that point and bounces. It can bounce this way or it can bounce this way also. So note it's bouncing like this, not like upward. So I can draw, now I can connect them. I can connect them. So that's how my graph looks like. So this is not my graph here. Anyone who did not understand? It's not compulsory it's going to bounce upward only. It can bounce downward also. When it was upward, I was not able to connect my graph. But if I draw downward, I can connect my graph easily. So that's how your graph looks like. Anyone has any doubt with this one? If one more example I want to do is, you're given fx as negative 2 x minus 1 whole square and then x plus 2. You're given this thing. Again, one way is you can solve, find the n, find your an and do it, and then solve the same way. Easier way of do it is, degree of this thing is, since it's already into factored form, degree of this thing is 0, I know. Degree of this thing is, so it's x minus 1 times x minus 1. So basically I can write x minus 1 square as, okay, let me do it in another step. So you had this as your problem. So you had fx is equal to, rather than writing x minus 1 square, I'm writing like this. Degree of this thing is 0, degree of this thing is 1, this thing is 1, this thing is 2. So if you need to find your final degree, you add these all. So you get 0 plus 1 plus 1 plus 2, which is equal to 4. So you found your final degree as 4. Now you're like, oh, I found my n as 4, but what's my an? Okay, what's the coefficient? Multiply the numbers. This thing has coefficient as negative 2. This thing has 1. This thing has coefficient as 1. Coefficient is a term next to x, and this has 1. Multiply all of them. For an you multiply. For degree you add. So you get negative 2. So when your n is odd, n is even and an is odd, what happens in this case? My graph is gonna be downward in both sides. This is easier way of doing it. Rather than multiplying the whole thing and doing it, what you can do is, see the degree of a constant term is 0. This term is 1. This term is 1. This term is, oh sorry, it's also 1. I'm sorry. It's also 1. So it becomes 3. I'm sorry. It's not 4. The power of x. So it becomes 3. Changes everything. And here the coefficient is negative 2, just a number. What's next to x? 1. What's next to x? 1. What's next to x here? 1. And multiply. For an you multiply, for degree you add. So you get odd and positive number. Odd and negative number. Odd and negative number, what's happened? First up and then bottom. It goes increasing to decreasing. I'm sorry, I wrote it wrong there. It's negative. Now step 2 in this case is very easy. Step 2 for x-intercepts. You don't have to make factors. They are already in factor forms. They are already factored. Put each and every term equal to 0. Put negative 2 equal to 0. Put x minus 1 is equal to 0. Put x minus 1 is equal to 0. Put x plus 2 is equal to 0. This cannot be possible. Negative 2 is not equal to 0. That's wrong. Let's solve this thing. You get x is equal to 1. From here you get x is equal to 1. From here you get x is equal to negative 2. You found your 3 zeros. So you have x is equal to 1, x is equal to 1, x is equal to negative 2. But I need to write them only once. So you get x is equal to 1, x is equal to negative 2. Okay, x is equal to 1 will have multiplicity as 2 because they are coming twice. Negative 2 will have multiplicity 1 because it's coming once. So I have 1 and I have negative 2 here. Okay. 1 has multiplicity 2, so it's going to touch and cross, I know. And a negative 2 has 1, so it's going to cross here. Let's find y-intercept. Put x is equal to 0, so you get y is equal to negative 2, 0 minus 1 square and 0 plus 2. When you solve, you get minus 2 times 1 times 2. You get negative 4. So you get 1, 2, 3, 4. This is your other point. So let's start joining them. So it goes here, it crosses here, it touches this point, turns around. Okay, now I cannot connect this. It's not compulsory. I told, only thing I know, it touches this point and crosses around. It can touch this way also, it can touch this way also. I cannot draw that way because if I draw that way, it will again cross x-axis and does not cross x-axis at that point. So it's gonna face downward and then I connect them. Connect with the bottom. This is not my. Any doubt with this thing? Okay. I'll take the names. Okay, that's attendance, and after that I'll take the names again for a few of the students I want to stay. Edward, Karen.
Wait, what?
Okay, no. Just I'm taking attendance right now. Eduardo. Karen.
Yeah.
Here.
Was.
Here.
Shira.
Here.
Samantha.
Here.
Angel. Miguel.
Here.
Hugo.
Here.
Christopher.
Here.
Joshua.
Here.
Erica. Gerald. Daniel is present. And Wandai. Present. Jesse. Jose. Is there?
Here.
Alejandro. Is there? Axel.
Here.
Axel is not there. Jalina.
I'm here. I'm Axel.
Axel, you were not there the whole lecture. I called your name like 5 to 6 times. I did not hear you from you.
I answered. I answered.
Okay.
He answered like a couple times, but I think you might have mistaken him for like Alejandro or something.
I think
Okay,
so too.
Okay. I'm Jalina. Carly.
Here.
Hawking. Nicholas. If I haven't taken your name, stay back, and I want these people to stay back. Angel, Miguel, Joshua, Erica, Daniel, and Axel, Jelena, Carly, Joshua, and Nicholas. And everyone for the test, I know most of you gave the test, but what I saw is some of you did not send your test on time. I told you to send me by 9. I gave you time till 9. I started receiving texts in 4:30 in the evening, or they're sending on Monday. I'm not gonna accept that. If you're sending me like that, you have to send me when time is assigned to you. You have to send me your work by 9. And some of you did not even send your work at all. I'm not gonna give you grade for that. For test, you have to send me. For quiz, I don't need any work, but for test, you have to send me the work. And yeah, tomorrow, I'm going to send you the link and I'm going to upload. And for the students, I call their name, stay back. And whoever's name I did not call out, those people also stay back. I mean, for the attendance. Thanks, guys.
You're doing the homework, right?
Yes, I'll be assigning homework right now. Yes.
Thank you. Have a good one.
You too.
Thank you. Bye.
Bye. Bye.
Miss K, I have a question.
Yeah.
Is it mandatory to buy the book? Because, you know, they're on my lab, you can like look at the book for
No,
free?
it's not mandatory. No.
Okay, I was just making sure. I was like, Jesus, that's a lot.
No. You don't have to buy it. If you bought it, that's good. I mean, I'm gonna do it further from the book, but if you don't have to. It's there
Okay.
already. Yeah.
Okay, thank you.
Yeah.
I just want to know that.
Yeah.
That's it.
No problem. Yeah.
Okay, see ya.
See you. Bye. Okay. So now I'm going to talk one by one. Can I have Angel first? Is Angel here?